Welcome back, nerds. Here's your bell ringer. Pause it, work it. You'll see the solution when you resume it in 3, 2, good luck playing music, 1. So, by popular demand, here is the second one. I want you guys to solve, there's not fractions, but there could have been, 4x to the fourth plus 4x cubed plus x squared. Right off the bat, how many solutions, I suppose we'll say equals 0. How many solutions are we expecting to find? 4. Can you remind me the name of the idea that you're using to determine that? That's right, the fundamental theorem of algebra. Cool. All right, give it a go, and then we'll jump back into law of sine stuff. Now, sorry about the screen. My computer died. Here's where we were. And I think we had gotten the first triangle, the big one, completely done, right? Okay. So the other little piece that I just want to highlight, and we were talking about it yesterday, I don't remember where we left off. I knew that this was 64 initially, and if I were to add another length of 12 right here, I'll do it in red so it matches, then this angle down here is also what? If that's 64, isosceles triangles have the same base angles. This is also 64 degrees. And that's how we got, I believe, to, if this is B1, here's B2. Was it 64.78, right? Okay. 64.78. Are we all at the same part now? Like you guys have the same stuff? Okay. How do you find angle B2? This one here. So 90 or 180? 180. I don't know what 180 minus 64 is. 115.22. Dang it. 116.22. Okay. Once we get that, and we recognize that, hey, there's really just an isosceles triangle that comes out. Can we get the third angle? Okay, I need to do the subtract from 180. $43.28. Okay, I'm trusting you guys, okay? Looks like it adds up. Okay. Doable? Okay, you will never notice the ambiguous case if you don't check. Yes, ma'am.
How would you know
Nope, go ahead and ask it, because
how would you know if it was an isosceles triangle or a triangle when you were to make
the second triangle.
yeah.
So, because remember that I have two lengths, the question was, how do I know whether or not it's truly going to be isosceles? And there's an easy answer. It has to be. This length cannot change, right? And alternatively, this length cannot change. So if I just take this length, no matter where I connect it, it's going to form an isosceles triangle, no matter what. Does that make sense? And I cut you off. Okay. All right. So today we get to see a little bit of the utility or the usefulness of the law of sines apart from just doing oblique triangles. Now, historically, when we've done this, and this is the last little piece of 6.1, historically, this has come off as formula stuff, and it's the reason why yesterday I used ABC and QRT, and I just changed the letters, because the letters don't matter. It's being able to recognize that the law of sines applies is what really matters to these things. So, today, I'm doing this differently than I ever have before, but we're going to talk about some of the utility, or usefulness, but I'm just going to write utility, or application, rather, of the law of sines. And I'm just going to shorthand LoS for my law of sines. Okay, and then just to make sure that we remember, side angle, side angle, and angle side. Those are the three law of sine situations. So, turns out one of the big applications is finding area. So if we have a triangle that's not right, it can be a challenge to find the height and the base, and there's a whole section in geometry where you have to graph them and then draw the perpendiculars and do all that. You can, that's fine, but one of the big applications of these things is the area of an oblique triangle. And all that this means is not a right triangle. Okay, now, for this, here's what I'm going to say. I'm going to have a small little picture in a couple minutes right here where we're going to generalize the idea that we discover. Because rather than just saying, hey, check it out, here's a formula, I think we can just do a problem, and then we'll be able to pick it out and make sense of what the formula is saying going that direction instead. Okay, so we're just going to jump right to an example. I'm going to leave just so you guys can see, and I don't really care if I spoil what's coming, although I kind of do. Here's my notes that I use as my guide. Here's the area of a oblique triangle. This little tiny section right here is all it takes me to generalize all of it. Just that. Little tiny piece. We're going to do a problem first and see if we can come up with a generalization from the problem. So, we are going to make a triangle, and I think in the context this is like a little plot of land somewhere where I have two sections and I know the lengths. So let's check it. We have example, and I'm just going to say area, and we'll do one together, and then I'll have you guys try one and we'll generalize this through. We have a triangular plot, so I don't care if it's like on a street or on a house, property doesn't matter. A triangular plot or piece of land with sides, and we have two sides given. We're told that one of these sides is a length of 84 meters, and the other side length is 55 meters. So two pieces, that's it. With, we're going to be a little bit more specific. We have an included angle, or an angle between them. I'm going to call it an included angle. Of, let's get a little crazy here, 115 degrees. Okay. All I want us to do from this is I want us to find the area. Okay. Now, there are a lot of ways you can do this problem. My goal for you is that we're going to find, to our understanding, the most efficient way to do this. Okay. Can we draw this? Yeah, I think so. So I'm going to sketch it, and it's not going to be perfect. I'm not going to measure it. But if, I'm just trying to think where I want it. I'm going to have my 84 right here. 84 meters. That's one side of my plot. And then the other one is shorter. And then you guys tell me when you think I'm at the correct angle. So I'll make it about this long. That's believable. Tell me when to stop. About there? Okay. This is my 55 meters. And then what's this angle? 115 degrees. Okay. So this is the exact law of sine situation. Right now we have a side, an angle, and a side, right? Okay, so maybe there's another way that we can knock this out. We're not using true law of sines. We're going to use it to make sense of. The third side, there's no option. It has to be right here. It has to be that one. Okay. Going through this, we are going to try to make a little bit of sense of this. Now, I don't really care which side we pick, but I have a good feeling as to what I would pick for my base. I'm going to physically move the triangle, just so we can see it easier. If I wanted to find the height of the triangle, do you agree that it doesn't really matter what side's down? You don't agree, or it doesn't matter? Okay, because I want this side on the bottom is what I'm thinking. Maybe, or I'll pick this side. We'll see. Okay, I'm going to draw this a few different ways. Could I draw this triangle like this? Like, it's the same triangle with 115 right here, right? Okay, and this would be 55, this would be 84. Now, if I wanted to draw the triangle like this, at what point, and I'm just going to label these so we can talk about them, A, B, C, at what point or vertex would you draw the height of my triangle? You would draw it from B, and it would go straight down to this side, right? Okay, now, if this is the height, do I have enough information to find it, do you think? Okay, so here's my challenge. Find it. Yep. I don't know that I agree with you, but we'll see. I want you to try it. Let's see if we can get it. While you're doing that, I'm going to draw this oriented a different way again. And you don't have to be able to visualize this triangle moving every time. That's not what we're after. So these are the three possibilities for how that triangle is aligned. Now, for this, I don't think the first one gives me enough info. Because if you want to try to do it, you can make a right triangle. You can use sine or cosine or tangent, but I don't have an angle to go from. So I can't do it. So this method is out. Okay, on this one, if I were to do the same thing, let's check it. This is my 115, and this must be my 55, and this would have been my 84, right? Okay, on this one, if I do the same thing, and I'm going to change my letters just so you know, because I'm not going to keep them straight. Let's say that this is x and y and z. If I wanted to draw the height or the altitude of this triangle, from which point would you draw it? Say it again. So I don't want to make the base yz. I want, like right now the way I've drawn it, the base is xz, because that's what everybody would naturally say the base is the bottom. Where would I draw the altitude from? You think I would just do it like this? But that was the same as this one, wasn't it? So I can't do it there, but check it out. Could you measure from the ground to how high it was right here, you think? Like, this is where my height would be on this triangle. Now, from this one, maybe we can make it work. If I do the same thing here, we'll call it QRS, RT, just kidding, where this is my 115. Where would the altitude be from this triangle? From the same, what do you mean? Give me a point. It'd be T down to here, right? Okay, so in either of these situations, either of these, I think we're good. Because all we need is the angle and a side. So I don't care which one we default to. Thoughts? You want to use triangle XYZ or QRT? Okay, so I'm gonna, like, these are all just will work right here. This one won't work. And you do not have to do this every time. But instead of just giving you the rule, we're trying to figure out how it's working. Okay, the other thing that I want you guys to help me do is I am going to change these letters. I only had them to talk about, but I want to make it consistent so we can possibly pick this out. Do you want to use ABC? Do you want to use something random? Okay, so help me out here. ABC. So BC is short. So this would be BC. This would be B and C. And then this one would have to be A and these other ones, right? So now they're all lined up the same. Same letter, same points. Okay. Purely by arbitrary choice, we're going to run forward with this one. And I'm just going to recopy it down. You will not have to draw them this many times every single time. Okay. Let's take this triangle that we had, and I'll make sure we label it ABC here with 115, 55, and 84. Okay. In this situation, it is completely okay to have the height living outside of our triangle. No issues with that. It forms a right angle with the base if it were to extend. And if I want to get the height h, I think we have enough to find it. Okay. Looking at it, I will label one more time. B is that one, C is there, and A is here. How do you find the height of this triangle? So I think you're backward, but I agree with you. Sean says, hey, these two angles right here are supplementary. So we're going to just take 180, minus 115, and it's what, 65? Okay, as soon as I know that this angle down here is 65 degrees, let's look. I have this angle, 65, and I'm trying to find this side of the little red triangle. Opposite or adjacent or hypotenuse? Opposite, and we know this side, which is the what of that red triangle? So which trig function has opposite and hypotenuse? Sine. So, S-O-H. So we get sine of, what is the angle we're going from? Love it. Sine of 65 degrees is equal to opposite is my height, h, over 84. Okay, find me the height of this triangle. 76.12. Okay, meters. Okay, we now have the base, or sorry, the height. How do you find the area of a triangle, though?
Base times side, or 1/2 base times height.
Okay, 1/2 the base times the height. Now, the way we oriented our triangle will wind up mattering. But we're going to see something awesome happen now because we're going to generalize it back with our letters. What's the base of this triangle, the one that's on the bottom? So this becomes 1/2 times 55. And then I'm going to use this 76.12 number for now, but we're going to dig in and see what really happened. Can your calculator handle this? I'm pretty sure it can.
No, 93.3.
93.3?
Why wouldn't it be able to handle it?
I think it could. It 100% it can.
Oh.
I'm just being dumb.
I see.
Yeah, you're good.
I was
Okay.
being serious.
So this process, seemingly everybody was comfortable. Huggins, you missed a part where I just rearranged a triangle different ways. But I want to check something out really quick. Okay. If we looked at this, I just want to see where all these numbers came from. This was to find the area, and I'm going to use area, and I'm actually going to write it out, and does it make sense? Okay. It's even going to get better. This is so awesome. Okay, it's 1/2 times, on our triangle, what side was the base? And by that I mean A, B, or C, based on the way we've labeled these. The base was side A, or segment BC, but remember this is angle A. This would have been side A. This would have been side B. This would have been side C, right? Okay, so let's just see what really spit out. Area is 1/2. Our base was side A. And our height came from 84, which was which side? It was C times the sine of what angle? Okay, so check this out. Two sides, and then the angle between them. We just took the sine of. Okay, if we look at this triangle, and you don't have to do it all, I'm just going to reason it out here as well. So this one, we can talk it out, but I don't need you to write it. This is my 55, this is my 84, right? Was this still 65 degrees? 115 and 65 still works, right? So my height in this one would have been sine of 65 is h over 55. So I would have gotten here the height is 55 times the sine of 65. Do you agree with that? And what was the base here? Which 84, and which side of the triangle would this have been? A, B, and C. That's side C, right? So if we were to try to do the same thing, I would realize that, hey, the area of this triangle would have come out to be 1/2 times the base, which you just told me was C, and 55 was side A. And we took the sine of which angle?
B.
Notice what happens no matter what triangle we use. 1/2 times A times C. 1/2 times A times C. And then the sine of the angle between them. Now, it just depends on what you're given. If I give you any two sides and the angle between them, this can be rearranged with different letters every single time. So let's try one more, and then we're going to generalize this. These problems, you never have to draw another triangle as long as you recognize that you have two sides and the included angle between them. Okay, so one more. I want you guys to try to do this without drawing triangles. If you have to draw them, that's okay, but I'm going to be way shorter with my writing. Sides of, let's say this time we get 24 inches and 18 inches with the included angle, let's say on this one is 80 degrees. The drawing, the main thing it'll do is help you pick 3 random letters, and you're going to be able to sort out how to plug them in just like we did before. I'm going to give you a moment. I'm going to try to do this without drawing. The drawings on the first one were only there so we could see that, hey, look, it does work. I know that this is just 1/2 times a side times the included angle, the sine of the included angle. Do we have two sides in the included angle? Boom. Check it out. The area of this thing then, give me one side. So I'll start with my 1/2 because I'll forget it if I don't. 1/2 times, here's one side that could be my base, 24. And then the other side, 18 times the sine of 80 degrees would give me the height in this particular arrangement. I don't have to draw it. I don't have to think about it. We have drawn the picture that generalizes everything. I just have a calculation. 216 times the sine of 80, whatever that is. 213? Point. 7.2 then? We're done. Like, I don't want to say it's pure plug and chug. If I were to draw the triangle to make sense of it, here's where I would suggest we stop. Because you guys can draw the heights and stuff like you were doing, but it doesn't matter. I'm going to make it so there's no base. 24, 18, and 80 degrees in between them. So maybe it's like this. 80 would be more like that. Okay, here's my triangle. 24, 18, and 80. As long as you recognize that this is what we have, boom, 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 we're done. Which means, to generalize this formula, right here, given, in each of these situations, what were we given? And by that I mean side, 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 angle, side, angle, angle, side, side, blah, 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 blah. I was given side, angle, side. Or more specifically, two sides and the, what did I keep referring to that angle as? That's between the given info? The something angle. Side, side, and included angle. That's like the formal word. The angle between the sides you know. So given this, let's just make it up. We have, we'll say, I don't know, sides Q, V, and angle theta. Like, letters don't matter at all. As long as we have this, we are golden. So let's run through it. The area of this thing, no matter what, it is, what's one of my lengths? Thank you. Every time I forget it. 1/2 times, what's one of my lengths? How about on this one? Q is one of them. So 1/2 Q times, what's the other side? V or R, however you read it, times sine of, what's the angle between them? Boom, we're done. Now, if you check your book, they use AB sine of C, and you can see the variations of it, but it really doesn't matter what it is. Just so you can see that, AB sine of C is one variation of this with the 1/2, because I'm going to forget it. Or I could do it differently. I could do 1/2 AC, and it'd be times the sine of, what do you think? B. Cool. It could be, maybe just by pure naming sake, I did C and B as sides, and I would take the sine of which angle? There's a pattern that's very clear once you start to see it. These are pieces of cake. Okay. Do you want to do a boat problem?
Boat?
A boat. Boats, boats, boats. Toy boat, toy boat, toy boat, toy boat, toy boat. Toy boat, toy boat, toy. Nope. All right. I think I have a boat problem on the homework. If we need to look at it, we will. We have like 8 minutes to get a little stuff done here. Have I collected anything from 6.1 yet? I don't think so. Okay, so I guess it's still 6.1. It's the last of it. Because we had a day where we did it and then I added to it.
You did not have to.
Are you sure?
You did. You know, you said yesterday after that it was going to be our homework for tonight. And you gave the homework to the people that are leaving.
Okay, yeah, that's one that I'm adding right now.
Okay.
Yeah, we're on the same page. Okay, I want you to add to whatever you have from page 409. I think it's, well, sure. 39 through 42?
What? Okay.
What?
You wrote something completely different.
For yesterday's people? What?
It was 29 to 33.
Oh man, I got some more stuff for you guys. All right, so if we need a work day tomorrow, like,
Okay.
you're not in trouble. The practice is good for you, I promise. 29 through 33. Now I see where I was wrong that one time for the first time ever. And 39 through, you know what, 41. I'll take one off. And let me look at what these three problems are to decide how crazy we want to go. Well, there's one more little bit. 49. Okay, we have a little bit of time now. It's all law of sines stuff. And there's one really awesome problem. I like 49. You will use a little bit of geometry in 49. Cool. All right. So we get a little bit of time. You guys have like 7 minutes. I would like you to at least casually start working on it so that if you have questions, we can deal with them. If I were to make a note card just based on this, so far I would have law of sines, and I'd have the formula for it. And then I would have the area of a triangle, and I'd have the formula for it. Piece of cake. All right. A few minutes here. I want you to act as though I'm collecting it tomorrow, but we're going to adhere to that 40-minute outside of class rule.